And then we're going to, Brian is after Andrew's talked a little bit, Brian's going to, has also got a little bit of a presentation, which is what we're doing with the plastics, which everybody perhaps knows a little bit about, but not the ins and outs. And do you want questions as we go along? Questions?
Oh, please just interrupt me and ask anything that interests you as we go along. And I have no particular place to kind of start and finish this, so whatever interests you, just ask me about it, and otherwise I'll sort of skip through fairly quickly. But probably it's very interesting and unusual environment for me to be talking in. So this is fabulous fun, because actually I am at heart a maker and a doer. I make stuff. I've been making stuff all my life. Unfortunately, I don't live in Norwich. Most convenient, but I was in a past life a professional wood turner for quite a few years, from the age of 11 actually, in some capacity or another, until I went to Sweden when I was 28. So I had quite a long and strange career doing bits of that, and I still make and do. And later I've got a slide or an instrument I've built based on making and doing actually. But just by way of introduction, of course you all know about plastics, so I don't need to tell you very much about this. But it always surprises me when I think about the fact that we've gone from this exciting new plastic house, unbreakable plates for housewives in the 1950s, to this mess. And that journey has taken us approximately 60 years, which is basically about my lifetime. And I find that really quite scary, that we can make that journey in such a short period of time. And what I always like to say at the start of these talks is that the plastic is a wonder material. Plastic is not the criminal in the current situation that the world finds itself in. It's our attitude to it that is the problem. The material itself is fabulous, as you're all exploring and finding out. And there are so many different types of plastic that have so many different intriguing, useful, exciting properties. And that's why people like to use them in these ultra high-tech composites and all kinds of things. Yet at the other end of the spectrum, we've got these things that are so cheap that everyone thinks they're just useless, disposable, single-use items. And unfortunately, this has led us to this sort of throwaway culture where people use it and they just toss it away. Maybe in the UK we're a little bit more enlightened than average, but you don't have to travel very far to find countries where people really still have appallingly bad attitudes to plastic, and they just think it's somebody else's problem. So I was in Crete a couple of years ago. Roadside verges completely strewn with plastic bottles that people just flung out of car windows as they drove past. And okay, some people do that in the UK, but not that many, I think. And this has led us to this kind of situation. There's a scary estimate here that if we carry on disposing of plastic waste the way we do currently, there's more plastic than fish in the ocean by 2050. And of course this leads us to this kind of situation with goes fishing net, disposed, abandoned, lost, fishing nets, all kinds of stuff like this, which is ending up in the nests of seabirds, which then get tangled up and it kills them. And really the hotspot of the global crisis that is plastic waste management at the moment is this area of Southeast Asia. And if this date is a little bit out of date, these numbers, but the situation probably hasn't changed that much. And if you look, 7 out of the top 8 countries for dispersal of plastic waste to the ocean, 7 out of the top 8 are in Southeast Asia. I don't know if any of you have looked at videos. There's lots and lots on the internet. You think you're going to a fabulous tropical holiday destination, maybe scuba diving holiday or something, and instead of swimming through pristine environments full of crystal clear water and tropical fish, you find you're swimming through a garbage patch of plastic waste that's just flowing past you constantly. So that's the reality in parts of Southeast Asia at the moment. And these kind of pictures I'm sure you've all seen. But that really brings me on to what I'm interested in as a researcher currently, and that's this world of microplastics. So I'm interested in all the stuff that you can barely see. So all the macroplastic, big stuff, is a problem, is a huge problem. But what you don't see is the fact that all this stuff gradually disintegrates and breaks down, and it gets smaller and smaller and smaller, and it's filling up the planet with tiny bits of microplastic. And these get dispersed by wind, by water, and ultimately they all get carried into the ocean, which is the sort of final resting place, if you like, of all this plastic waste. You'll be familiar with some of these materials. These are so-called primary microplastics because they're actually made micro-sized deliberately because of their function. Somebody mentioned to me microparticles in cosmetics and toothpaste and stuff. They're now banned in the UK, in the US and in most of Europe, but many other countries in the world they're still not banned. Kind of things you might be using in this interesting space. These are epoxy powder coating particles, which are, of course are individual microplastic clothing fibres. These are polyester clothing fibres, and one of my favourite enemy materials, wet wipes. Many of you, all of you probably are aware that the majority of wet wipes are actually made out of polypropylene or polyester, or sometimes mixed just with cellulose. But a very large number of them are made out of plastic. And the manufacturers of those wipes, they have no interest in changing that because they make an enormous amount of money out of them. We're addicted to them in the UK. There's roughly 11 billion of them sold every year in the UK. And yeah, quite a large proportion of them are plastic.
Is there a way of telling us are there better brands?
There's all kinds of different wipes you can get. There are polyester ones, there are polypropylene ones. The best ones are made out of cellulose. You can get, within the cellulose category, you can get ones that are genuinely kind of, that fall apart and break up, that are flushable, that can be put down toilets. And you also get a lot of cellulose ones that are made out of regenerated cellulose. So this is like viscose clothing fibres. And they're much tougher and they don't disintegrate. You can't flush them. Well, you can, but they don't disintegrate. But they do at least biodegrade. So if they go into landfill, they do decompose over a sensible time scale. So they're much the best ones. The problem is they're not labelled. So right at the moment you have no way of knowing, and the only way we could figure it out was by taking them in the lab and measuring them all spectroscopically to work out what they were made from. So if anyone's interested, I've got a sheet, not with me, but at work, with all the common brands and what they're made out of. So if you want to
If we could get a copy.
have an interest in that, that's fine. I can pass that on to you. 2021, the EU is legislating, but of course we're not necessarily going to be part of that anymore. So it's up to the British government what they choose to do, and whether they're going to stay in the pocket of the wet wipe industry or whether they're going to do something about it. Well, you don't read my guess. Okay, tea bags. You all know about tea bags. Tea bags are full of plastic. Your average tea bag contains 50 milligrams of polypropylene fibre. I don't know, I'm looking around. Have you got any tea bags? They're in the cupboard. Right. I won't ask you what brand they are, but some are better than others. Some contain plastic, some
Can I
don't.
ask a question on that? Because it was only recently that I found out that was the case, and I actually found it quite shocking, to be honest.
It is shocking, and most people don't realise it. Yeah.
When that's letting off, so it's made of plastic fibres, and I'm assuming later when it breaks down it releases microplastic, or will it do it actually as part of its function, right? So are you going to end up with small bits of plastic in your cup of tea?
Ah, right. Okay, that's
And what
There
is
is a piece of Canadian research that states that nylon mesh tea bags, and actually there aren't very many brands of nylon mesh tea bags in the UK.
Tea pigs.
Tea pigs aren't actually nylon; they're made out of polylactide, which I can come on to in a moment. The nylon mesh ones, this Canadian study, because Teavana, which is sold by Starbucks, I think, we were using nylon mesh tea bags, at least in the US and Canada, which is why this Canadian study used them. And they claimed that 11 billion micro and nanoplastics fragmented off a tea bag when it was used to brew a cup of tea. We've been trying desperately hard to find lots of microplastics shed off tea bags. I've got some project students working on it right now, and the best evidence we have is certainly in the small range, so down to about 2 microns in size. We're finding it really hard to find many. You find the odd one, but
It's later on down the road once they've been disposed.
yeah. So I don't think there could be lots of nanoplastics because our methodology doesn't pick them up. We simply can't see them.
So if we put ours in the compost, which we do,
if you put them in the compost, in your garden compost, none of them will break down very well. Most of the common brands of kind of square and round tea bags have polypropylene fibres, about 50 milligrams per bag, and that's the same sort of net mesh structure as your sort of non-woven wet wipe. It's just much sort of thinner tissue of it, and that will probably not break down for hundreds of years. If it's in bright sunlight, it will gradually break down into smaller and smaller particles, but it won't completely disintegrate back to carbon dioxide.
So the answer
break
really
down.
is to get the infusion things and loose tea.
The best thing you can possibly do is a nice metal mesh infuser and some loose tea. Failing that, the stitched and stapled tea bags are good because they contain no plastic. Which brands do them? Probably Pucker.
Clipper.
The Clipper ones are not bad because the plastic's actually used to glue the bags together. That's why they put it in. They use a thermal fusion process to melt the plastic, and that's what seals it around the edge. Clipper and a few other PG tips and one or two other brands have switched from using polypropylene to using polylactide. And polylactide is it's a biologically derived polymer, so the feedstock is not oil-based, and it does degrade in the environment, but rather slowly. So it breaks down reasonably okay in high-temperature commercial composting, but it's really, really slow in your domestic compost. So it will go eventually, but it'll probably take quite a few years to fully break down.
I think Lavazza have just brought out compostable coffee pods, and I think that's probably...
That may well be the same kind of material.
Sort of
and unfortunately, there's an enormous amount of misinformation in the all the product advertising literature and so forth. So tea pigs, I think you mentioned. Tea pigs for a very long time claimed that there was no plastic anywhere near their products and they were all super clean and terribly ecological, and it was all fine, and it wasn't plastic. It was they were made from cornstarch. And it's kind of true because the polylactide was probably made by fermenting cornstarch, but it's not made out of cornstarch. It doesn't biodegrade like cornstarch does. It's actually, I mean, it could equally well come from any other biological feedstock that you can make lactic acid from. So that's kind of, a bit of a misleading statement, and I don't know if they made that statement in the full knowledge of what it was to be deliberately misleading, or whether they genuinely didn't understand that because it's a bioplastic, it's still plastic.
Probably a case of people hearing what they want to hear,
Yeah, yeah.
which I think is true at a consumer level as well.
Marketers got hold
Yeah,
of it and decided to...
you never know who made the influence. But I took them in the lab and measured them. I knew what they were made from, and then I went through their website to try and find the information. And I eventually found that somewhere in a response to a question that somebody had sent into a technical kind of product query line, there was a note that actually conceded that it was made from polylactide, which was made from cornstarch. So they did state it, but not in a very obvious way. But actually now they have changed their marketing, I think, because there's been so much publicity about it. They maybe decided to come clean, or felt more comfortable coming clean because they look better than all the people that are using polypropylene. So suddenly maybe it's become a benefit to claim that rather than a danger. I don't know.
Are you aware of any health studies about perhaps negative benefits of tea bags then, because a thing I heard recently to do with whales and the large stuff is if it fills up their gut and then they sort of starve or can't eat. There's obviously that large scale mechanism, but you're not aware of any small scale of toxic or poisoning effects.
There's very, very little evidence at the moment about that. Certainly not in humans. We know next to nothing. We don't know if microplastics pass through the human gut wall into the bloodstream, or through the lung epithelium into the bloodstream. We don't know. There's some few sort of model studies on animals and cell cultures and things that suggest that nanoparticles do that, but plastic microparticles, we don't really know.
It's fairly obviously a new area, isn't it?
And if they do that, probably not very many of them. So the question is it enough to really do you any harm, or do they carry anything with them which is toxic enough to do you any harm? And I think at the moment the jury is certainly out, because there's almost no evidence to base any assertions on. I'm not aware of much work going on in the UK on that. The Dutch have been quite proactive. They've got 20 or so pilot studies underway looking at different aspects of that question to just try and get some preliminary information about these simple questions. Do particles cross the gut wall, for instance? But very little's known about that at the moment.
Yes, it's more food chemistry than plastic, but there is another area to do with where bakeries have been told to turn their ovens down because of this other chemical thing called acrylamide.
Oh, acrylamide and Maillard reactions.
Is that
that's
an
all
evil,
getting
nasty carcinogen, or not so bad?
Acrylamide is really quite toxic. It used to be used very widely in laboratories by biochemists, and I got a PhD in biochemistry, so that's where I started. And I spent years mixing these things together and pouring gels out of them. And now, if you want to weigh it out in the lab, you have to wear respirators and stuff. They're much more concerned about the toxicity of it, because it's demonstrated to be cumulatively neurotoxic. So if you expose yourself to reasonable levels of it on a sort of semi-continuous basis, it will do some very nasty things to you. The amount you get in a bag of potato crisps, probably don't need to worry too much, provided you're not eating them kind of 5 times a day. It most likely won't do anything too terrible to you. But I mean that is an example of something that is in lab studies genuinely known to be
So like
very
mercury
significantly.
or something like that.
It is known to be a pretty toxic chemical, actually. I mean, not quite in mercury sense, but it's
that cumulative.
it has a cumulative negative impact that you would want to avoid. Okay, so I've covered lots of things. So the second way that microplastics get into the environment is, of course, breakdown of large plastic objects. So these are some photos I took on Southwell Beach a couple of years ago. I was there a couple of weeks ago, took a load more photos. Seems to be particularly good for plastic waste. I don't know why, but all these things you will have seen them on local beaches gradually breaking up. And of course the reason they do that is does this work? Maybe it will work. Maybe it won't. Oh, it doesn't really.
It should be.
Oh,
be
there we
playing
go.
it.
We've got this fantastic mixing and grinding machine called the Seashore, and the combination of those high energy rolling waves and all the grit that go and small stones that go with it is a very, very effective tool for grinding up plastics. And just to demonstrate that, here's a nice little piece of hard, most likely polypropylene or maybe high density polythene, which came probably from a fish box. That's on a black volcanic sand beach in Iceland, and you can see that it's all been nicely sort of tumbled and rounded off through the action of sand and waves. And what you need to think about is not the piece you see, but all the pieces that you don't see,
Like sand.
because they've been ground off and they're all tiny fragments. And the problem with this is the numbers game. So as the macroplastics break down into microplastics, you very rapidly get huge numbers of particles. So roughly 10 grams or 10 to 15 grams in a 500 milliliter sort of disposable drink bottle. So that gives you 10 million 100 micron particles, so they're about the size of a grain of sand. So you won't see them, but you get 10 million of those, or bits the size of dust or pollen grains. Get about 10,000 million of those from a single bottle. And I don't know, you might know. Does anybody know how many plastic disposable bottles we use in the UK every year?
Too many.
Too many for sure. Okay, the number I've seen quoted is 13,000 million bottles a year, and I thought, nah, can't be. Oh, we don't use anything like that many. And I was feeling sort of self-righteous about it, and then I started to sort of roughly tot up how many we do use, and we don't buy fizzy drinks in bottles, but we buy milk in bottles, and I've got 2 kids, and we drink a lot of milk, so that's 4 2-litre pots of milk every week, and then there's the ketchup bottles and the shampoo bottles and all this other stuff, and it very, very quickly tots up, and I'm pretty sure we're not at the average of 200 and something per person, but it's, you know, everyone, even, well, a few of you might have time to shop ecologically enough to avoid them, but it's actually really hard work to not buy them. You have to try really hard. So, yeah, vast numbers of these bottles. And actually, more interesting than other things, I might say, I'll paint you a little picture just to let you imagine what 13 billion plastic bottles look like. Okay, if you line them up across the table, a metre of plastic bottles is about a dozen or 14, something like that. And I did a calculation that tells me if you take the M25 and you line up plastic bottles all around the periphery of the M25, and you've got a team of incredibly dexterous elves running round and round and round, lining up all these plastic bottles continuously, and you then get in your car and you drive 24/7, 365 days a year, at 70 miles an hour around the M25, just going round and round and round and round and round, you will never get to the front end of the line. That's how many bottles we're using in the UK every year. And it's kind of unimaginable to me that it could be that many. But I've checked the calculation loads and loads of times, and I'm pretty sure the maths is right. So it just gives you an idea what the problem might be. And of course, it's not just the plastic itself. The plastic itself may or may not be really toxic, but the plastic has a couple of problems associated with it. One of them, sometimes it contains sorts of additives to help it with its function. So things like flame retardants or special cleaning agents or anti-fouling agents are put into the plastics to stop them degrading in the environment. And plastics, because they're hydrophobic, they're oily on the surface, lots and lots of toxic chemicals absorb really strongly on the surface of plastic particles. And this means that they can also act as little vehicles that carry this stuff around and actually transport it into whatever's eating them. So that is potentially another quite serious mechanism that might cause toxicity, and probably does cause toxicity in lots of small organisms, worms, invertebrates, things like that, that are eating these little plastic fragments in the environment.
What's in that? You've got cigarette butts in.
Oh yeah, sorry, that was cigarette butts.
In
I'll
that
go back. Let me
container.
just go back. Where were they? Yeah, here we go. Yeah, this is from, I think it was, I can't remember who this one was. Let's say on it. It was a charity based in London that collected these. But yeah, it just says there are 400 toxic chemicals that have been identified as products of combustion of tobacco. So they get sucked through the cigarette butts and then people flip them away. The butts themselves are made of cellulose acetate fibre, which is moderately biodegradable. It has at least chemistry that organisms can get at. So potentially over time it will eventually biodegrade. But obviously if it's full of 400 potentially toxic chemicals, it's going to slow down the degradation process quite a bit, probably.
And let them leach into them.
And they can also leach into the water, maybe get picked up by other plastic particles, get carried around, and so forth. So, yeah, it's all really quite a difficult situation. I'm just looking what's coming next in my talk, and I think probably I won't talk about all the methods to detect them because that's kind of technical analytical chemistry. It's probably not that interesting, but I will just show you this because I said I make stuff. Okay, here's my XYZ translation stage, which some of you will recognise because it's not very different from the one you've got on your milling machine here. So that's just moving. Basically, it's just moving a camera around over an object so that I can photograph it in lots of little pieces, and then you stitch all the photos together so you get a high resolution image. And that allows you to detect very small objects. Got one here, so we can go down. That's an old version. The new version goes down to about 2 microns, so we can detect microplastic particles down to about 2 micrometers using that rig.
This is just optically you detect them then?
It's the methodology. The actual detection is pure optics.
Yeah.
This is fluorescence. So we're exciting. Well, we've adsorbed a fluorescent dye onto the surface of the plastic particles,
Right.
and then we illuminate them with intense blue light and photograph them through an orange filter, so you don't see the blue, and all you see is the bright yellow, orange, red fluorescence of the plastic particles. So that allows you to spot them. This is a sample from Hakefield Beach. And you can see all these bits of wood and grit and stuff. They're dark, they don't show up, but the plastic particles glow brightly, so you can spot them, and then you can measure them from the optical images and count them and so forth. So that's methodology that we've developed to do that. And maybe just finish with this, because some of you might remember this story a couple of years ago, the revelation that bottled water contains lots of microplastics. This study wasn't actually done by me, but it was done using the method that I've just kind of outlined there. And yeah, they found that bottled drinking water contains lots of microplastic particles. Some of them probably come from the bottles themselves or the lids, But there are actually lots of types of plastic in bottled water that have nothing to do with either the bottle or the lid. So it's quite obvious they didn't come from the packaging material. So the question is, where did they come from? How did they get in there? Where's the dust contaminating the system? Or where are they getting reintroduced? Because in some cases this water is actually purified to a very high level. Yeah, sorry.
Have they looked at tap water? How much is in tap
Yeah, there are far fewer studies on tap water, but we've looked at a bit at tap water in Norwich. It contains some microplastics. On average, about the same or a bit less than you get in bottled water. So, yeah, it's kind of quite similar levels.
So water has plastics, whether you get it out of the tap or the bottle.
Yeah, there are. As far as we can see, it has. There's a big study was commissioned by the UK water industry. It was done by the Centre for Ecology and Hydrology, and they claimed there were almost no plastics in the water, but they only looked at things bigger than 10 microns, and they filtered it so aggressively through stainless steel mesh filters that I suspect a lot of stuff went through. So I'm not entirely confident that them. I'm sure their numbers are what they measured, but I'm not sure that the way they chose to measure it is quite revealing. And when we filter it on 2 micron or 0.4 micron filters, we find lots more particles, but not silly numbers. I mean, it's sort of, maybe 10, 20 per litre. The worst sample we looked at was about 100 per litre, which is 2 or 3 times what you get in typical bottled water. But again, the bottled water varies quite a bit actually in what it contains.
Would you find the same amount in, say, a bottle of Coke as you would the bottled water, or do they tend? Is it something that they do to filter it?
The answer is I don't know, because it's actually much harder to measure it in Coke, because there are plant extracts and stuff in there as well, which make the assay a little bit more difficult. You have to pre-process the samples much more to get an accurate estimate from it, whereas the water, because it contains almost nothing else, it's kind of easy to measure, which is why we haven't actually looked at that question. There's a study on beer, it's done in Germany, of course, as you might imagine. There were microplastics in beer, but that's probably because there were microplastics in the water that they put in the beer, or it might have come from the hops, because I mean there's loads of airborne pollution that might have gone on that, or on the barley. It's still traditionally malted, most of it, in open malt houses. They even deliberately aerate them to stop it going mouldy and stuff. So there's lots of air going through that, and probably airborne microplastics are getting deposited all over it. So that was not a surprise, really. I mean, we're in here, we're walking around on a plastic floor in shoes that have synthetic rubber soles mostly. We're wearing clothes, some of which have fibres on, so it's all around us, it's blowing all over us. You can't avoid it. Don't think you can. If you want to live, you can't avoid it, really. Even in pristine, high alpine environments, there's a recent study that showed that there's significant amounts of airborne microplastics in the high Alps in Switzerland and Austria. So even on that skiing holiday in a beautiful semi-remote area, there's still stuff blowing around. And they found it in the Arctic, they found it in the Antarctic, they found it at the bottom of the Mariana Trench. So I reckon there's nowhere you can go, basically. Okay, I shall stop talking and then let others.
Brian, so
Do you want me to?
are there any other questions?
Yeah, if
before-
anyone's got any questions, happy to talk. I'm here all evening, I think. So if you've got any questions that occur to me, do just say so. Shall I unplug this for you?
Yeah. Shall I? Do from the same bit, shall I? And then make life easier.
Thank you very much.
Thank you.